Alright, so now we're going to take a look at how we go about sketching cubic functions when they're given to us in some kind of factorized form. But before we do that, I want to take a look at some of the key features of a cubic function in relation to its equation, focusing on how some of the factors of a cubic function may affect the x-intercepts of the graph. Now, the most basic cubic function that we can get is when we've got something like ax cubed, where this a value is not equal to 0. What we do know about this a value though, in terms of its graph, is it controls the general shape of the graph. So for example, if my a value is greater than 0, what it tends to do with the graph is it tends to make it climb up the hill as we go left to right. That's sort of how I remember it. Where if our a value is negative, so it's less than 0, it tends to do the opposite. It tends to go down the hill as we go left to right, something like that. Now, when we go to look at cubic functions in its factorized form, the a value is always represented by the value in front. So that's going to determine the overall shape of the function itself. But now let's take a look at some of the common factors that we might come across when we start graphing these cubic polynomials. Now, the three type of factors that we might need to consider when we're going to be graphing these from their functions is a linear factor, a repeated factor, or repeated linear factor, also known as a squared linear factor, and a cubed linear factor, such as these here. Now, what each of these will tell us is how it cuts or meets the x-intercept, or the x-axis. Now, if we've got this linear factor like this, what this is going to simply indicate to our x-axis here is the function itself is simply going to cut through or pass through this axis like this in some manner. It's going to cut it at that point. Whereas if we've got a repeated root such as the one here, with our x-axis, how it's going to interact with it is it's going to come either from above or below, but it's just going to touch the x-axis. So it's going to come down here, just touch it, and then keep going back in the direction that it came. So that's what happens if we've got this repeated root. So it's going to come down and touch it, and then keep going back the way that it came, either above or below the x-axis. Where if we've got this cubed linear factor, how it's going to interact with the x-axis is a little bit different again. What's going to happen with our x-axis is the graph, either starting from below or above, it can go either way, is going to come and meet the x-axis at a flat stationary point and then keep going. Now, this flat stationary point we call a stationary point of inflection, but that's how it's going to interact with the x-axis. Now, it's important that we keep this in mind when we start looking at graphing these equations from their functions themselves. So now, let's have a look at that. So now, let's take a look at how we use the axes-intercepts to sketch the graph of these following cubic polynomials. So the first one that I've got here, you'll notice that I've got 3 linear factors. What that means is it's going to cut the x-axis at each of these factors' points. So the very first thing I need to do is to determine where it's going to cut the x-axis. So the x-intercepts here are going to be the opposite sign of each one of these. So it's going to be -3, +1, and +3. Now from here, the other intercept that I'm going to need to be able to graph this is the y-intercept. And of course, the y-intercept always occurs when our x is equal to 0. So what we do here is we substitute 0 in for our x in each one of these. So when I do that, this will be 2 multiplied by 3 multiplied by -1 and multiplied by -3. So now essentially I multiply this out. So 2 times 3 is 6, times -1 is going to be -6, times -3 is going to be +18. So our y is equal to 18. So therefore our y-intercept is 18. So once I've got this information, what I want to do now is sketch this graph and indicate where these key points that I've found are on the graph. So let me just go ahead and do that. and now I've got the information indicated on my graph, I now determine what type of shape that this cubic's going to have. Now, because my A is positive, what it means is it's going to be climbing up the hill as it goes. So it's going to be taking this general shape like this. And you can see that if it's going to take this shape, it has to go up through here, turn around at some point, come back through here, turn around at some point again, and then go back up through. So I sort of want to sketch that the best that I can. And so it goes up here, it'll turn around at some point and cut through there. It'll come through and cut back through here, turn around at some point again, and cut back through here. And look something like this. So what I want to do now is just label this graph. And what I've now got is the cubic polynomial sketched out with all the axes intercepts indicated. And once again, because it's only got linear factors such as these, it's going to indicate that it's going to cut through at each one of those points. But what happens if we've got something with a repeated linear factor such as this one? Well, let's take a look at that. Now, the very first thing I want to indicate here is my value of A. So the value of A here was 2 before. The value of A here is negative, so it's -1. Now, because it's negative, it's less than 0, it's actually going to be going downhill as we're going. So it's going to be the opposite shape of this. It's going to be starting up here. It's going to wriggle somehow. It's going to keep going down. So I need to keep that in mind as I'm going to graph it. But the process that we follow is very similar. We start with the x-intercepts, where it's going to cut the x-axis. Now it's going to cut the x-axis at this linear factor here. So this x-intercept here is going to be opposite sign, so it'll be negative, and then it'll be 1/2. That's where it's going to cut the x-axis. But it's going to also touch the x-axis at the repeated linear factor here. So it touches this x-axis here, so it touches the x-axis at +2 because of that linear, repeated linear factor. Now, the other thing I need to find out is the y-intercept. So I find that when x is equal to 0. Now, when x equals 0, I substitute 0 in for my x value here. So my y will equal the negative of -2 all squared multiplied by +1 overall. So -2 all squared is going to be +4. +4 multiplied by -1 is going to be -4. Multiplied by 1 is just -4. So therefore my y-intercept is -4. Now I've got all that information like before, I want to go ahead and sketch a graph with these key points here, the y-intercept at -4 and the x-intercept at -0.5, and where it touches at +2. And now I've done that, keeping in mind my value of A, it's going to be going downhill. So it's got to cut through the first one. So it's got to come down here somewhere and cut through this point. It's got to turn around over here somewhere and come back and just touch at this point and then keep coming. So I also start with the repeated root and draw in where it's going to touch. And then I've got to work out, it's going to cut through these points in here. It's going to turn around at some point like this. And then keep going and keep going. So we'll end up looking something like this. The final thing that I'll need to do is include, like in this one, a label for the graph. So, as you can see here, the steps of graphing these cubic polynomials when they're in their factorised form is we essentially find the x-intercepts, or find where they cut through the x-axis if they're linear factors, find where they touch the x-axis if we've got a repeated linear factor, and if we've got a cube linear factor, what it's going to do is it's going to have that stationary point of inflection at that x-intercept instead. But we identified those points and those characteristics of the graph. The next thing we need to identify is where the y-intercept is, which is always when x is equal to 0. Once we've got that information, we put that information, those key points, on the graph itself, and we sketch the polynomial. Remembering that we've got to look at the value of a to determine whether overall it's climbing up the hill or climbing down the hill. That's the sort of way that I remember it anyway. Alright, after that you've just got to label your graph and you're done.